We're thrilled to have you with us for the next 45 minutes or so to talk about Google's serverless compute options, which you can all use today, and some you'll be able to use in the near future. My name is Alexi.
And my name is Guillaume.
And we will cover Cloud Functions, App Engine, with all the new exciting features some of you have heard of already, maybe, that were announced yesterday, as well as in this morning's keynote. We will also highlight a multi-service demo spanning across multiple products, multiple languages, and finally, we'll have a glimpse at the future of serverless containers. Now, let's get started. But first, what is important for your company? What do you do as a developer for your company? Well, hopefully, you create applications and functionality that matters to your users. And to do that, if you were to deploy your application on your own infrastructure, you would have to deal with a number of things, such as selecting that infrastructure, buying the hardware potentially, configuring the operating system, deciding whether you're going to use containers or not, defining what kind of storage strategy you have, and so forth, configuring the network, the load balancing, the logging, and all of these things. So building a pipeline of continuous integration is maybe something else you need to take care of. And on top of that, the company needs to worry about security patches, maintaining everything in good shape. And all of these operational tasks are very important things, and you need to do all of these before you can start writing any code. So let me introduce you to Google's new serverless data center. No, obviously, this is, you all know, the joke never gets old, but serverless does involve servers, actually lots of servers. Besides, this is a really old building, way too dirty to be a data center. The key here, though, is that as a developer, you do not need to manage the servers. You do not need to install OS updates, patches. You do not need to set up monitoring, auto-scaling, or configure any kind of load balancing. We offer to do it for you. So here's our little attempt to define serverless in two different ways. The first one is really an operational model, and I think most people here are familiar with that. You don't manage the servers. You don't even see them. You don't see the abstraction of a server. You're higher up the stack. The other aspect of that is, of course, that it auto-scales. If you have traffic, we will make sure we have enough resources to serve that traffic. And of course, we will have the ability to scale from 0 to almost infinity. And we will bill you for that. That is also part of the deal. So you will pay for the usage. No usage, no bill. That's the other part. Now, second, we believe it's also a programming paradigm. One would say a cloud-native way of developing applications. Instead of shipping code that bundles a lot of libraries as part of the application, instead you consume services that are otherwise exposed as such. And you do expose maybe yourself a few functionalities as services. So instead of having a very tightly coupled, intertwined set of features, your application has services, and maybe this is event-driven, and rather than having synchronous calls between services, you're also able to take in asynchronous, event-driven calls. Now, serverless, as you can see, is way more than just functions, bits of code running in the cloud. It can be compute. We'll definitely talk about that today. But it spans across many other things, such as databases, where you did not see the concept of a server. All you want is a persistent service. That's really all you really need. Data warehousing, analytics, data processing and ETL, or even machine learning training that can be done without having to set up any sort of cluster, and of course, without having to resize or manage those clusters. So compute on its own is not enough. You need all of those. But let's focus on compute for a moment. Serverless on GCP. Of course, you can map all of these things to lots of different products that we have, but we'll focus on Cloud Functions and App Engine. which are the two products that we have. Both of them are generally available, as you'll see in a moment. But we will focus on those while using some of the other services. We will be using Cloud PubSub, a highly scalable messaging system that can be used to build some really scalable applications. We will use Cloud Data Store. We will not use BigQuery, although this is an amazing product which basically takes your data and your queries and returns insights, results to your SQL queries in interactive time, and without having to understand how this is all deployed. So again, we're in the serverless realm. But let's go back to compute. Cloud Functions and App Engine. So Cloud Functions is functions as a service, if you are into acronyms. And App Engine is platform as a service for those old enough to remember that acronym. So why two? Why have two products? Well, let's find out. The great things about choice is that it enables you to adapt to different requirements that you might have. But the other side of it is, of course, that you need to understand what kind of choice you're making and what the drawbacks might be. So let's take a moment and review both products as they're available to you today. So let's probably start with functions and Guillaume.
Thank you. All right. So more and more, our applications, our infrastructure is becoming more and more event-driven. So we're interested in events that are being emitted by some kind of service, application, API, etc., and that are intercepted here, in our case, by Cloud Functions, which is going to respond to events. Inside our function, we can also trigger new events or invoke other services, APIs, store some data in Cloud Data Store, file in cloud storage, etc. The unit of work for Cloud Functions is, as the name implies, a function. So a function, it's a small unit of work with a fine-grained, small focus. There are two ways to trigger your function. So either synchronous calls with HTTP, or just a mere HTTP, a GET or POST, or etc., or more asynchronous events. So, for example, new files stored in cloud storage, or a new message on a PubSub topic, which can trigger your function. Some examples of where you can use functions. So typically, one example I'm going to take with the HTTP call, that's if you're building a chatbot, for example, with Dialogflow for the Google Assistant, you can define a webhook within the Dialogflow UI to say, okay, when there's some need for business logic for fetching some data or something from the chatbot, then call this function. Similarly, if you're using GitHub for your source code, there's commit hooks which allow you to be notified when there's a new pull request, when there's a new commit coming up in your source tree. So that's for the synchronous calls with HTTP. But another example, that's what we're also going to use in the demo later on, for example, with pictures being uploaded to cloud storage. So you want to create thumbnails, you want to crop the picture or do something with that picture. Once it's stored in storage, your function is notified, it is triggered. In the demo, as you shall see, we're going to use the newly announced Cloud Scheduler. So whenever, at regular intervals of time, let's say in my case, I'm using Cloud Scheduler for triggering an event every 1 minute, so I'm going to get a little message. So there are different ways of using the Cloud Scheduler, but in my case, I'm going to use the PubSub mechanism or pipe to get the message to trigger one of my functions. And all that, obviously, oh yeah, another example that was interesting that was given yesterday, I think, by Orientation. That was, for example, with Stackdriver, you can create alerts when something happens. For example, you can see by looking through the logs that something happens that is unusual. You could also specify that the alert pings your function. So that's an interesting use case for further automating your infrastructure, your whole project. So from a developer perspective, sorry, from a developer perspective, what you deploy is really just code, basically. So as a developer, you just focus on who's a developer in the audience. Yeah, quite a few hands, nice. If you're a developer, you focus on your code, and you don't necessarily want, upfront in particular, to have to think about servers, about creating clusters, about managing those servers, all the provisioning, all that stuff. Now, at some point, if your application is very successful, you're going to need to be able to, scale. And well, it's not always easy to scale your architecture to cope with incoming traffic and traffic spikes. But also, a nice aspect of serverless, it's auto-scaling down. So from 0 to n, that's nice, but also from n back to 1 or 0. That's also something that's important to do. And of course, you don't want to pay for nothing, basically. So if your code is not running, you're not going to be built. So that's, yeah, pay only for what you use, right? From your functions, so I mentioned a few triggers, cloud storage, PubSub, etc. But from your functions, you can call all the services you want. So you have at your disposal things like various kind of databases, data store, spanner, big table, etc. You have access to all the machine learning APIs. That's what we're going to do with the demo, with the Vision API. You take advantage of all the logging capabilities, error reporting of Stackdriver. So it's one, how to say that, a big bag of things that you can take advantage of within the code of your functions. So as you learned about yesterday, Cloud Functions is generally available with a 99.5% service level agreement. It's also available across different regions, 4 regions, 2 in the US, 1 in Europe, 1 in Asia. What's interesting to know as well is that your functions, they don't have to all be in one and single region, but you can have functions in Europe, functions in the US, within the same GCP project. So if you want to have functions that are closer to your users, you can do that. You have modern runtimes, so the newly announced runtimes, Node 8, for using things like async await to make your code easier to read when handling promises, etc. Python 3.7, so that's the very latest and greatest Python, with a thin Flask framework for defining your functions, and there are also more languages coming soon. In terms of the common features, I already mentioned all the error reporting, logging capabilities, which is always nice when you're developing, debugging, and if you have got some production issues, you want to trace back what actually happened. A very important aspect, that's the build and dependency resolution in the cloud. So you don't have to, for example, when you use Node modules, some may require some libraries or need to be compiled because there's some native code. So you don't have to cross-compile things locally, upload the modules and things like that. It's really in the cloud that this dependency resolution and build is being done. So it's one thing less to think about, really just focus on defining your dependencies and writing your code. I think there was something else. When I was mentioning dependencies, your functions are actually running on an Ubuntu image under the hood, and there are several libraries that are already pre-installed. So, for example, things like FFmpeg for dealing with videos, ImageMagick if you want to do some stuff with your pictures, but you also have all the set of libraries that are required to run Chrome in headless mode. So, for example, if you want to have a function that takes screenshots or generates PDFs from a particular web page, if you want to do some kind of end-to-end testing where your function actually controls a browser, a Chrome headless browser, you can do that easily with Cloud Functions today. All right. So the newest capabilities that have been announced as well, that's the VPC and VPN access. So you can say when you deploy your function that your function is tied to a particular VPN network. So with that, what that means is that, let's say you already have some VMs running on Compute Engine, your function is able to access those VMs and chat with those VMs. So it's not two separate worlds anymore. In addition to that, related to security, you have also IAM role binding. So if you want to say, okay, this function should be called only by that role or etc. This is now possible. So instead of having a function that is publicly available on the cloud via HTTP, for example, you have finer-grained control now in terms of secure access. We also introduced scaling controls. So it's especially for limiting actually the number of instances of one particular function. So this can be useful for things like cost control, of course, but also let's say you have a function that calls a database, and instead of overloading the database with too many connections, if you cannot have, let's say, more than 100 connections, you can say, okay, I don't want more than 100 functions to be running to avoid the problem of draining the connections and having connections issue with your database. Before it was GA, it is already GA, but it's not yet. So all this stuff, except environment variables, which are already available, but this stuff is coming till the end of the year. So what I wanted to say about the Cloud SQL Direct Connect is that so far, and as of today, you had to go through the internet if you wanted to access a Cloud SQL instance. But now with the upcoming Direct Connect Cloud SQL, I mixed the words, you get it. You are able to go through the Google network directly without going outside through the internet to get access to your database. Last but not least, environment variables. So with functions, you're able to define your environment variables. For example, if you want to define different kind of environments, prod, dev, staging, or if you have any pieces of configuration that shouldn't really be stored in your source code, in your source tree, in your repository, can be passed as environment variables. And we'll see an example in the demo where I am actually using environment variables. All right, that's about it for functions. Let's see a bit more about App Engine.
Yep, let's switch gears and talk about App Engine. Actually, no, the demo will come just a little bit later. Can we go back to slides? So the fundamental difference with Cloud Functions here is, well, in the name. The unit of computing, of deployment, if you will, here is an app. So an app obviously is coarser grained than a function. It might be interesting if you're moving from a monolith to the cloud. Moving from a monolith to function-based programming and full microservices might be a bridge too far for many people. Instead, App Engine may be a better fit, and still in the realm of serverless, where we take care of a lot of things for you, as we already said. But as we will see, you are still, in App Engine, able to structure your code. And that, we believe, is important. So the unit is the application, the trigger is HTTP, and it's best used for migrating, we believe, existing applications, and generally speaking, for HTTP services. Most developers will have preferred languages. I know I do. And expect to use them with no constraints. Like, don't tell me to use that proprietary API. Don't tell me you cannot use that set of libraries. I would like to be able to use this in what we call idiomatic ways, which is any habit that I have, I would like to be able to take this to the cloud. We'll come back to this. This is really important. To deploy your application, there's really no configuration needed. It's a gcloud, our SDK command line, app deploy, and it will look at your artifacts, your application, and it will deploy this. And once deployed, similar as with functions, you'll be able to auto-scale from 0 to a lot and back to 0. Billing is done accordingly, no traffic, no cost. So App Engine today. App Engine is 10 years old. So that's a decade of a lot of things. And some of you might have seen App Engine not evolve quite a bit for the last few years. And the reason for that is that the team has been hard at work on a new infrastructure and a new sandbox technology, which enables a lot of things, security being the most important. But for you developers, there are a few things coming with that as well. So first of all, we have generally available the Java 8 runtime, which enables not only Java 8 and all the features that come with it, such as Lambda expressions, pipelines, streams, but also all the languages running on the JVM, such as Scala, Kotlin, Groovy. So that is really something that a lot of people use. The second thing is, just as with functions, we support Node 8, currently in beta. In the next 30 days, you will have access to Python and PHP with very modern and recent versions as well. And more features, more languages, more updates are coming soon. We also have a new instance scheduler, that logic that says how many and how quickly and how often I need to spin up new instances, and what is the logic behind scaling down, which is really, I would think, the secret sauce behind App Engine, is new. And that was released a couple of months ago. We believe it's more predictable, so you understand why it's doing the things it's doing. It offers better utilization with less cold starts. So when you hit an instance that is hit for the first time, well, there's less of that. And it offers new settings to balance cost versus performance. And we believe we have faster deployments, which is always important. We do a lot of things when we deploy. We're deploying across a cluster. I mean, the cluster is there, you just don't see it. So we need to do a lot of checks before we can say that the app is live and running. And we believe we can do that better. And if you're in the healthcare industry, you'll be happy to note that as of, again, a few months ago, we are now HIPAA compliant. Now, let's go back to this idiomatic way of developing apps. We call this the second generation idiomatic runtimes, and this is enabled by a technology called Visor. Anybody who's heard of Visor here before? Just a few people. This is really cool technology. You don't have to really understand how it works. You can just rip the benefits. It is an open source technology that we've announced at the last KubeCon, so a few months ago. It is a new sandbox technology, which offers this idiomatic developer experience. You can use any API, any library that you want, and it should just work. Any module from the official Node.js package manager, such as Headless Chrome, which Guillaume mentioned, any Java jar library, any Python library. You do not need to change your code in the way it uses those libraries. At most, you should have to add maybe some metadata to your application in the form of some YAML or XML, just to describe it, to give it a version number, and that's really it. Note, by the way, that everything I'm describing here, all the benefits of Visor, is something we're using both in Cloud Functions and in App Engine. Now, this is not a new feature, but I think it's important we spend a minute on it. App Engine, because application can have multiple distinct layers or modules, say a front end, some business logic, some data access layers, some admin piece, as you'll see in the demo, it's interesting to be able to split your application in different modules or services. In App Engine, you can do that, of course. Each service has a version. Potentially, all those versions, by the way, are active at the same time, and you'll see why that could be useful. And each version can be scaled independently from the other one. You probably don't have the same scaling needs for some admin backend with 2 people accessing it, and the front end, which is for the world to use. So we believe it's a great fit for microservices. Each service can also be written in a different language. There's really no constraints there. And if that makes sense for you, you can certainly take advantage of that. But maybe more powerful, this built-in feature, multiple services active at the same time, enables things such as service level upgrades, A/B testing, canary releases, all of that with something we call traffic splitting. Traffic splitting is not a new feature either, but it proves to be extremely powerful and I would say trivial or very easy to enable. Once you've given a module, a service, a name, which is free-form, you could call it 1, 2, 3, 5, you could call it beta, green, red, blue, whatever you'd like. You do this in the config file. Once you have that, you can start addressing and sending parts of the traffic to a new version. That enables for you, and this is based on IP address, on cookie, or completely at random. So this allows you to do something like A/B testing. Maybe you will be offering shipping costs to 50% of your users, or you'll be offering a general discount on your goods to the other 50%, and you'll see which one works best. So that's something you can do. And of course, you can also do canary releases. Deploy a new app to a few percentage of your users, see how it behaves, and as you increase confidence and you see no errors, you start sending more load, more traffic, and eventually you move the entire traffic to it. Or you go back because you've found something that's really bad. And no code changes, no config changes in terms of changing any XML or YAML file. This is all done very simply from the command line or from the UI. And of course, traces and logs can be used to filter by version. And this is where you can see that something's going good or not so good, and you might need to roll back. So those of you that have been using App Engine for several years, you might have seen that a number of App Engine specific features have graduated into a standalone product. The most famous of them has been Data Store, which might seem crazy, but back in the days, you had to use App Engine to access this amazing NoSQL backend that we have. There are many more services that we'd like to point out, but there's 2 that we'd like to point out. They're fairly new, and that can be used from App Engine, from Cloud Functions, or maybe even if you're still running on a VM on Compute Engine that you can use and that are now standalone GCP product. The first one is called Cloud Tasks, which will soon be in beta. I think the official thing is in the next 30 days, so stay tuned.
Yeah.
Initially, this was an App Engine feature, task queues, and it's coming soon as a standalone and fully managed service. It will take care of executing, dispatching, and delivering a large number of distributed tasks. Using this, you can perform work asynchronously outside of the user requests and process requests in batches. So this is a great way to scale your architecture. The main architectural benefit here is really to be able to decouple the user requests from scaling all those microservices. In the beta release, you'll have support for Python, Java, and Node. And you'll be able to set things such as rate limits, retry configs. And this will be, I believe, something that's fairly useful for building scalable microservices architectures. Next is Google Cloud Scheduler. Well, this is really cron in the cloud. Nothing super fancy, but this is something that a lot of people need. And we believe that what we have now with Cloud Scheduler, which we'll show briefly in the demo, is the ability to configure regularly scheduled tasks and have them operate at those regular intervals. So common use cases are being able to send an email report on a daily basis, maybe update some cache data every 10 minutes, or update some summary information every hour. This is also probably the most elegant solution to the frequently requested feature of invoking functions at regular intervals. So again, this is not tied to a product. This is a product of its own and can be used to trigger jobs and manage all of them in one place rather than have and reinvent this cron feature in different parts of your architecture. And of course, you can hit HTTP endpoints, pops up topics, or relative URL handlers to hit App Engine apps. And this will be made available in the next 30 days. Now, before I hand it over to Guillaume for the demo, we will be walking through some slides to explain what we built with all the technology that we've just discussed. And hopefully, this will be interesting to you. Over to you, Guillaume.
Thank you. So I decided to create a little picture sharing application. So if you want to try it, you can go to picadaily.appspot.com. So with this application, you can take pictures of stuff around you. So you can feel free to create a picture right away if you want. Selfies, whatever. As you can see, there's the picture. There's a little color around it. That's the main color of the dominant color of the picture. We'll see why this is important later on. We also see tags. This is actually what the Vision API tells me. OK, in that picture, I see, I don't know, was it interior, cushion, furniture, bed, etc. And so if you click on the pink camera button, you can do I'll do it later on. I'll take a picture of myself on stage. So you can choose the camera you want. And after that, there's also the little tags icon in the menu and the icons on the top. You can also have a look at the most frequent tags, most frequent labels that have been recognized. And so that's the first App Engine service. And I also have another service, which is our admin backend, basically, just for Alexi and myself to see. So you can see two tabs, published and filtered, because with the Vision API, I'm checking that nobody uploaded something weird, and I can publish and unpublish stuff. So this is the main ideas in that little demo. So what's happening? So a user takes a picture. The picture, so via the web page, via JavaScript, the picture is sent to the main App Engine service, the front end, which defines a web API where I can post my picture. When that picture is taken and sent to my app, we're going to store that picture in cloud storage. When this happens, the cloud storage, and before I mention what happens to the picture, we also add some metadata, like the URL, basically, or the name of the picture in data store. When that picture arrives on cloud storage, a function is triggered. This function is going to call the Vision API to get labels, so that's the tags you see below the pictures, to get the color, the dominant color. That's why the pictures were framed with some colors. And we're also using the filter, the save search annotation, which tells you if the content contains adult, racy, violent, medical content, and that kind of stuff. When the Vision API answers the request, the function actually adds metadata in the data store. So again, the labels, color, filters, etc. in the entry we created when we uploaded the picture. So that's one thing. When if you remember the popular tags page, in the popular tags, So the way I implemented it, it was a bit of an afterthought, but I'm actually going through all the metadata stored in data store. So I'm going through all the lines in my data store. So it's not the most efficient way to do that. So it's an expensive query which takes time to run. Actually, for the few hundreds or thousands of pictures that I have, it's pretty fast. But let's imagine I've got millions of pictures, and if I have to go through all those pictures, the query might take a little bit more time. So instead, what I'm doing is that I'm taking actually a snapshot of the most frequent pictures that I'm storing again in data store. So that way, I don't have to do the costly operation. I just have to do a read, a simple read operation in the data store rather than going through all the results. So App Engine for the front end, 2 functions in Node.js, and we have a second service in App Engine, which is the admin interface. All right, so let's see that on the demo machine. So as everybody knows, the internet has been invented for sharing pictures and videos of cats. So let me introduce you to Shuket, she's called. It's a 1.5 months old little baby cat, a little kitty. So here I'm looking at the cat tag. So I have a few, I love my cat. So I have a few pictures of my cat, all right? You can see the latest pictures. Yeah, thank you for uploading some picture. Yeah, that's cool. Thanks a lot for that. I can also take one. Hey, Alexi, come. Okay. So that was the new picture button, and here you can also see the tags, so the most frequent tags. I don't know which one I could have a look at, like flowers. There are a few flowers that have been uploaded from, well, that's from my garden. Oh, and there's your tennis racket somewhere. I think it's in recreation or fun, perhaps. I don't remember where it is. No, fun. Oh, that's fun. Yeah.
That's cool.
That's fun. Okay, that's cool. Oh, yeah. We were very serious earlier. All right. So yeah, that's how a quick introduction to this application. So thanks for sharing your own pictures, and feel free to add additional pictures later on. Oh yeah, I need to show you the admin interface as well. So here, there shouldn't be. Where is it? There are some broken links. That's strange. Interestingly, some of your pictures have been filtered. Spoof. Okay. This one is racy, I don't know why. Or like this one, it almost looks like blood, so there's violence, but it's actually my dessert. So I'm sorry, that's not blood. Anyway, so sometimes, the Vision API, it could be blood, but it's just some strawberry or something, some jam. So let's have a look at how this has been implemented, right? So here I'm going to show you, first I'll start with the Java app, which is the main app that you are using. So I used a small framework called Spark Java, which is a very lightweight framework, so that's nice for App Engine. I have a few routes, so this is the root of the website. I have tags, so for example, when I was navigating via tags, like, I don't know, black font, whatever. So you can see in the URL tags/black. So this is tags :tag. There's a part I could have created another service for that one, actually, the pure API part, which is not for the visual web front end, but which is used by the admin API as well as by so it's a Vue.js JavaScript application which calls this API part. So there's a post request here, for example, /API/pictures. When you post there, you can post the picture. So when I'm doing that, you can see that I'm creating a new entry in the data store. That's where I'm going to store the metadata for my picture. And I'm also using the cloud storage, creating getting the bucket and adding a new file in my bucket. And then I return some JSON content. Perhaps I can show you one more. So like this one, that's the one which gets all the all the pictures basically. So I've got a query. I go over the picture kind. I order by the most recent pictures. I just want to see the top 20, and then I'm returning. So I didn't fully implement pagination, but I was using the cursor to be able to do pagination. But that's for the next version. Of my startup of picture sharing, and then I'm returning the JSON payload thanks to the JSON library. So this is the basically what the API and front end code looks like. There's perhaps in the resources, for example, I could also show you like this one. That's the Vue.js code, which actually calls, thanks to the fetch API, which calls my backend. So /API/pictures, potentially with a tag. And then the JavaScript code updates the page, single page app style, to show the pictures, especially when I navigate from tags to tags. So that's the main app here. Now let's have a quick look at the admin service. So the admin service, so initially I was, when I wanted to, tweak the metadata or delete a picture or unpublish or publish a particular picture, I was going through the cloud console and go through the console just to do my little updates. But as I was a bit in a rush, one of our colleagues, Valentin, who's a Go developer, told me, "Hey, by the way, I can do a little admin API, admin front end for you if you want." So he created a Go application, a Go App Engine application with some jQuery. And I styled it in the same style of the rest of the application. And so you can see the published picture, and it's interesting because there's a bug that wasn't there this morning. I don't know why. And as you could see, so you can zoom in, you can see the reasons why something was filtered, and I can potentially delete. So for example, I don't know, I can delete this one. Well, you get the idea. So this one, pictures.go. So that's my second module. There are a few routes that have been defined to get the pictures, do the filtering, deleting pictures. There's a struct to define the structure of the data that's in the data store, creating keys for the data store, and let's have a look, let's say, at the list of pictures. So again, we're doing a query on all the pictures, defining some order, filtered, processed, by timestamps, etc. So it's just some plain Go code. And as you remember, when you see here all the little tags, they are actually coming from the Vision API. So when the picture is uploading on cloud storage, I'm triggering the function that I'm going to show you right now. So we saw some Java, we saw some Go. So now let's have a look at some JavaScript with Node. So here I'm receiving an event. The event is actually in terms of the data that's stored in that event object. It contains the file name of the picture and the bucket in which this picture is stored. So what I'm doing there is that I'm going to prepare a query for the Vision API. So label detection, I want the image properties to be able to get the dominant color, safe search for filtering. I'm calling the API here. Once I get the API, I go, the call is successful, I get through the JSON to find the right information. And then I'm going to store some updates to the metadata for the file. So I'm going to store the main color, the labels, etc., back into the data store. Yes, and the other one, so as I said, computing the most frequent tags is an expensive operation, so I decided to do some snapshots once every minute. So I defined a cron of, well, once every minute, please call my function. So this is the second function, which is here. So first of all, notice that I used the new feature environment variables here. So I can access the environment variable by using process.env the name of my environment variable. So I have a default value just in case it's not passed as parameters. But if you look at the functions here in the console, popular tags, which is here, you can see down there, environment variables, API endpoint, I define the URL of the endpoint. All right? What am I doing here? So I'm not really interested in any data from the event because it's really just once every minute. So there's no data that I actually need. And then I'm doing the frequency calculation and storing the most frequent tags in the data store again. So that's about it for the code. So again, you see, so there were, previously there were some errors when I was developing those functions. You can see the actual usage there. So there are really two functions. Popular tags, which is a message via a topic. Cloud Scheduler pushes a message on the Cloud Pub Sub. And here there's a bucket. That's the bucket where I stored my pictures. And I'd like to show you two things. So this morning I did a load. So it was, this morning. So it's a bit small. But if you remember in the abstract, we said, scale from 0 to 1,000. So I did, I created some load injectors to be able to try to go up to 1,000. So I can't zoom in because it's gone, but I managed to go up to 938 instances created in just a couple of minutes by adding more load and more load injectors. And at some point, I really had like almost 600 APIs, instances running. And the other thing I wanted to mention, a feature that I particularly like, so when you look at the services, so the versions, sorry, I have two versions for my application here. So this is the normal version, but I also have a gray version. So if I want to do some A/B testing to see if users prefer a gray background instead of white, I can easily do, here in the console, I can easily do split traffic at random. I want to add a new version, and for example, I want this new, the gray version to get a bit of traffic. So I'm updating those settings, so you can do it with the gcloud command line. And once in a while, you should see a different background, white, gray at some point? Yeah, gray at some point. So it's fairly easy to do traffic splitting for A/B testing, canary releases, green-blue deployments, and so on. All right, that's it. Let's switch back to the slides.
Thank you, Guillaume. So let's recap quickly what we've seen. We've seen an application deployed across Cloud Functions and App Engine with multiple functions written in JavaScript with Node and one App Engine app using multiple services. All of this including idiomatic language runtime, such as Node, obviously, for the functions, Java 8, and Go for the admin part. We've used multiple GCP services, again, both functions and App Engine. The reason you want to use those services is that you're able to access the power of GCP. You use the Vision API, which is one of the main pieces that gets you all these tags, but we've used a number of additional services as well. Things that we haven't shown too much, but we have a reference to another talk that we encourage you to go to, is how Stackdriver aggregates all the logs from all the parts of your application and provides you with very interesting information, both for developing and for managing the application. You know, giving away responsibility of scaling the application doesn't mean giving away all the ops job and keeping you from seeing what's really happening. Quite the opposite, in fact. And of course, this was fully serverless. No server was harmed in this demo. Now, what you've seen is that we're able to take your artifacts, whether they come in the form of a function, a collection of functions, an app with one or multiple modules, and that's great. And we do this, and we take those artifacts and we auto-scale them, and it's a pay-per-use model. Now, increasingly, people are packaging their code into containers for various reasons. So what if we were able to offer you, the developer, the choice of taking not just functions or apps as deployment units, but also containers, and still offer that serverless operational model with auto-scalability and pay-per-use. So here are a couple of upcoming options that we're excited to share with you and that have been that were announced and covered this morning in the keynote. The first one is called serverless containers. Imagine we have containers that are stateless, that comply to some request response signature. The promise here of serverless containers is to offer that auto-scalability, health checks for applications packaged in those containers with arbitrary libraries. So imagine a random or any Docker file with any base image, an arbitrary set of libraries or language runtime, be able to deploy this with a command that you are familiar with, gcloud functions, deploy, and simply adding this option of pointing to that particular container that, again, it needs to be stateless. Well, if you do that, our job will be to provide you that serverless environment where we auto-scale and do all the health checks and all the monitoring that is required. No servers, and still pay only while the code runs. If you'd like to sign up for the EAP that is coming before the end of this year, g.co/serverless containers. And this is gcloud functions deploy. Now, a second option is the serverless add-on for GKE, and this was also discussed this morning. So whether we're talking GKE, which we know and love in Google Cloud Platform, or the GKE on-prem, which was just announced as well, here what we have is a one-step install technology built on Knative. If you haven't seen Knative, you probably want to look at this. It's an open source project that's helping make those artifacts that you deploy portable. And in this case, we use this and we built the serverless add-on for JKE on Knative. And this, what it allows is for you to deploy, this time with a new artifact, the deploy with not only the container, but also the cluster, the Kubernetes cluster, whether it's on-prem or JKE, that you would like to target. And the reason we'd like to do this or to offer this as an option is if you were to reuse an infrastructure that you already have, that you already know. Or maybe you would like to have some custom VM sizes in that JKE cluster or GPUs. So with all those reasons, we have yet another option for you to deploy serverless workloads, this time on JKE. So it's time to scale down to 0. So Guillaume, I want to thank you, but we need quickly to conclude.
Yep. So whenever you've got small units of code that you need in an event-driven approach, functions are definitely a great fit. For bigger business logic, long-running web apps, web API, or backends, App Engine is really awesome and scales like Snapchat style. And serverless add-on for when you need more portability, more control on where you're actually running, or if you need special resources like GPUs or that kind of stuff. So it's up to you, and you can mix everything together. There are some more sessions happening tomorrow. Yeah. So thanks again for your attention, and see you soon.
Thank you.